Welcome to another API Spotlight. The goal of this video is to cover the Java multi-threading API. This video won't be a complete guide to the multi-threading library as there is too much to go over in a short video, but it should be a good primer to other videos out there on the topic. Typically when creating a program, we imagine the program as a step-by-step execution of the code that we write. This limits our code to running on a single CPU, and given that CPU clock speeds haven't increased much in the past while, means that this kind of program is unlikely to get much faster in the near term. Multi-threading, on the other hand, allows you to write programs that can run multiple lines of code at the same time. This allows programs to be much faster and increase in speed as CPUs with more cores come out. The basics of multi-threading are very similar to what you're used to. Here you can see we have a class that implements the Runnable interface, and as such requires that we override the oneRun method that it provides. If we want to run this code normally, we can create an instance of the class and then call the corresponding run method, as you can see here. This produces a very predictable output and will print all of the messages one after the next. As we implemented the Runnable interface, we can now leverage the threading API that Java provides. Here you can see we're passing the Runnable into a new thread object and calling the start method to start the thread. With just a single thread, you don't see much difference with the output. It'll still show the messages in the same order that they're defined. The true magic happens when you introduce multiple threads into the mix. Here is such an example. When we run the program, you can see that the messages are intermixed between the threads. This is because the threads are running at the same time, and the outputs of the threads will be intertwined. As you probably are thinking, this allows for some very powerful designs, and can be used to create much faster programs than using just a single thread. With this power, though, you have to be very careful. There is quite a bit of responsibility when you're using multiple threads. One such example is state. When multiple threads are running at the same time, they can also modify state at the same time. Depending on the ordering of when threads execute, you can run into what's called a race condition. Race conditions are caused by multiple threads modifying the contents of a variable at the exact same time and can cause very unexpected results. This is discussed in more detail in the Java Synchronization API Spotlight. Sometimes it is helpful to pause the execution of our thread while others are working. The main way to do that is through the sleep method, as you can see here. The sleep method takes time in milliseconds, so it is usually helpful to use a more readable format to produce the milliseconds. In this case, we are using the duration class to create more readable code. Once sleeping, it is often helpful to be able to wake the thread up before it is done. One reason this might be necessary is if you want to quit the program after it has started. Typically with a program, you can do this by using a keyboard interrupt. The same sort of method works for stopping a thread that is stuck sleeping. The equivalent method is the Thread.interrupt method. This will cause an interrupted exception to be thrown everywhere that a thread is currently waiting. In this case, the sleep method would throw an interrupted exception. Best practice in this case is to continue the interruption all the way until you quit the thread. To do this, we need to set the interrupted flag again, as the flag was cleared by the exception. For further information about Java's multi-threading API, there are links provided down in the description below. If you found the information helpful and want to see more videos in the future, please comment down below on which APIs you would like covered in future videos. Thank you.